So in this video we're going to talk about the Fluke oscilloscope, model number PM3084. This manual for the oscilloscope dates from November 98 and it can be found on the internet. The link is up there and I'll put it also in the video description. And this is our oscilloscope. This is how you're going to find it on the lab table. Let's try to set it up. The first thing is to do the handle. To be able to put the handle correctly without breaking it, gently pull from the sides and then lift it up and let it click into place. And your oscilloscope is in the correct position now. Okay, now let's plug this in. I have this kind of cable. It goes to the back of the device. And the next thing is I go and switch the power on. The first thing we need to do is to hit this AutoSet button to let it calibrate itself. Now looking a little bit closely on the device, we see that the numbers are very blurred. In order to change that, you have to play with the focus knob here. So it's already getting a little bit better. And I think this is a pretty good focus at this point. Now let's see what is written on this screen. It says channel 1 is set to 50 millivolts alternating, and the time interval is 1 milliseconds, and channel 1 triggers on the up tick of the signal. So what that means is that 50 millivolt alternating, meaning each of these big lines, which is sort of the centimeter line or the graphical lines, they are 50 millivolts in this case. And then the MTB 1 millisecond, again, the time interval is 1 millisecond. So the vertically is the voltage, 50 millivolts vertically, and horizontally each of these big lines is 1 millisecond. And then the channel 1 is triggered on the uptick. Just to understand the squiggly signal, that means the AC mode, and that's changed to a DC mode, which we will see later what that means from here. And if you want to see the ground calibration, you just click on this ground and you see this inverse T sign that's showing the ground. So the ground is at 0, so it's correctly placed at 0, and that's because we did the AutoSet setting. Now the next thing is we have this kind of cable. On one end it's a BNC connector. On the other end it has two alligator clips. Now one of them has a red and the other one has a black. So you actually don't need to use the black at this stage. You can just use the red to connect your channel 1. So we will plug this BNC into channel 1 and we will connect this red to the probe adjust, which is here. And as you can see in the probe adjust, it says 600 millivolts, 2 kilohertz square signal. Now, we're not seeing anything at the moment because we're in the ground mode, right? So it's not showing the alternating current, or not scanning anything. It's just showing the ground level of the oscilloscope setting. Now, if I go to AC or DC mode, the AC mode is in 1 millisecond and 50 millivolts, and we're not seeing anything. Let's go to the DC mode. In the DC mode, I'm seeing broken lines. Now, what that means is that the signal that's coming through has a 0-volt component part of the time, and part of the time some other component which we cannot see at this point on the scale. Now, the probe adjust was saying it's 600 millivolts and 2 kilohertz, meaning that the peak of the signal should be 600 millivolts, and at the moment my setting is 50 millivolts, which means that each one of these things is 50 millivolts. So in this scale, 600 millivolts would be way out of the range. So therefore, what I need to do is I need to adjust the amplitude of channel 1. So we're on channel 1. I go to the channel 1 screen and I adjust the amplitude of channel 1 like this. So now each square is 0.1 volt. Now each square is 0.2 volts. So now each square is 0.2, 1, 2, 3, so 0.6 volts, which is 600 millivolts. Everything is in the range. Now what's difficult to read is now the time signal. So the time base is right now 1 millisecond. Now this one is saying 2 kilohertz. So it should be, the cycle of it should be 0.5 milliseconds. So 2 kilohertz means 0.5 millisecond cycle. And if one of my boxes here is 1 millisecond, then it will be 2 cycles that fit in. And approximately 2 cycles are fitting in. So ground, high, 2 cycles are fitting in. But this is now very difficult to read. So what I do is I go to this section, which is the time adjustment. And on the time adjustment, I put the MTB to be able to see everything more clearly. Okay? The only thing is the beginning and the end of the signal. So the signal is slightly below 0 here and slightly below 0.6 volts. And the time scan is starting at some arbitrary point. What would be nice is to start the time scan on one of these major lines. To do that, I can change the X position of the scope. So if I change the X position of the scope from here, what I will do, so with this X position, what I will do is I can bring, what I'm trying to do is I'm trying to bring this edge to the main line. Okay, so now I've brought it to the main line. And in the Y position, so to bring the bottom to ground, I can simply push it up on the Y position and it comes to exactly 0. So for this calibration signal, what we are seeing is that, let's say the signal is starting here and it's repeating itself here. Now, because this is now each graticle is 0.1 milliseconds, we have 1, 2, 3, 4, and a bit. So I think we would call this point 4.6 or 4.7. So 4.7 times 0.1 millisecond gives us 0.47 milliseconds. Now what this is saying, the probe adjust, is it should be 2 kilohertz, which is 0.5 milliseconds. So there is a discrepancy between the stated probe adjust signal and what the oscilloscope is showing, and despite the fact that we've done the AutoSet. Let's now get the function generator. This is our function generator. In the same way, we can use this handle to adjust it or leave it in this position. At the moment, if I'm sitting it on top of the oscilloscope, I think I can leave it in this position. So the function generator also has a power cable which we can plug it in. And then this button was already pressed, but this is the on-off button. So we can turn it on. Right, so it's already showing something on the screen. So to connect the the signal generator, we need a BNC cable that has a BNC connector on both sides. And we would put, so this is channel 1. I'll put it on channel 1 output, and I'll put this one here to channel 1 input. So let's understand how this signal generator works. At the moment we're in channel 1. If we want to switch channels, we have to go here. So now this is showing channel 2. I go back to channel 1 because I'm on channel 1. So important thing is I'm currently not outputting anything. So the output button is not illuminated. So I need to put something to the output to be able to see on the scope. The one thing is, you will be able to, if you bring this amplitude way down in the scope, you will see this this side of a jitter. Now this is basically noise that's coming across this this button. So this is basically noise. So ignore that because we're at the 2 millivolt scale for the one big reading, and this thing is at 10 volts. So if it was putting something out, we wouldn't see this amplitude at all. Okay, so so therefore bring this. So we're looking at 10 volt amplitude. So therefore, let's bring our amplitude to by pressing this thing. We should read here for each box maybe 2 volts or 5 volts. Okay. So if I see 5 volts in each box, then 10 volt peak to peak, it should be between the first line in the bottom and the first line on the top, just above that middle line, the ground line. It should be just doing something like this. If my amplitude is set at 10 volts peak to peak. Okay, and this is 3000 hertz, so 3 kilohertz. What I can do is I can press on this frequency knob, and with this frequency I can either set the frequency. If I push it again, I can set the period, so frequency or period. So 333 microseconds or 0.33 milliseconds corresponds to 3000 kilohertz, and it's the number basically 1 over 3000, right? So 1 over 3000 is 0.33 milliseconds. So let's change this with this knob. We can change it to 2 kilohertz, exactly as as what we were reading here before on the probe adjust of the scope. Okay, and we have 10 volt PP. So now if we let's see what our time variation is, 0.1 milliseconds, and we should get this thing to 0.2 milliseconds should be fine, and let's output. So now we're outputting a sine signal, and to understand its frequency, we can just push this, and I'm bringing like this point to 0 approximately, and then what I can do is I can read this point, or I can make the time granularity a bit better, and I can set the exposition such that this intersects here and it intersects over there. So basically I have 1, 2, 3, 4, 5 big grid lines, meaning 5 big grid lines at 0.1 milliseconds each. It's exactly 0.5 milliseconds. So this signal, this sine signal that we get here corresponds to 2 kilohertz, which is exactly, so I can look at if I switch this, I say the period is 500 microseconds, which is 0.5 milliseconds. So everything fits, and this measures it exactly. Now, the other thing that we can do is obviously we can change this waveform to a square wave. So if I click on this waveform here, square wave, and I again adjust the X position through this to bring one of these edges to one of the large grid points, then I can see that this is, well, almost 5 of them, and 5 point maybe something, so approximately 0.5 milliseconds. And the other thing is, this is triggering on the down signal. So when the signal is going down, it's triggering. I can change that to an up signal with this, and we see that the trigger is triggering on the up signal. So let's understand this signal generator again. Right now, we're seeing each unit is 5 volts, so a total of 10 volts between the peak and the trough. And it's offset by 0 volt DC. I set it to it's 0 volt DC. So now what I want to do is I want to set this offset to maybe 3 volt DC. What I can do simply is I'm in the offset mode. I set 3, and then it asks me which unit. And I say, this is volt DC. I said 3 volt DC. So now my wave is offset at 3 volts and 10 peak to peak, around 3 volts. So if we want to see the amplitude, it's 10 volts. But if I press again, it shows me the high-low level. So the high-low level is between 8 and -2, which is shifted by 3 from -5 and 5. Okay? And on the screen here, I see that the top one is basically 1 and a bit. So that corresponds to 8 volts, and this one corresponds to -2 volts. So this is again showing the how it's matching there.